Okay. 11, it says in a simple random sample of 400 teenagers, 230 of them admitted to be texting while driving. What is the sample proportion? So what is the proportion from the sample? So this is just going to be 230 out of 400. So that's 230 divided by 400. 0.575. So we're going to say P hat equals 0.575. Okay, so find a 90% confidence interval for the true proportion of teenagers that admit to texting while driving. That's going to be in our calculator. We're going to go to the stat menu, over to the tests, and we're going to do keep going down, 1 prop z interval. We're talking about a proportion, 1 proportion. I'm going to hit that. The number of people in my sample who texted was 230. Size of my sample is 400. Confidence level I want is 90%. And we'll hit calculate. So it looks like he doesn't give us any rounding, so we'll just say 0.5343. 5343 is a good point. 5343 to 61.6157. Okay, you can write your interval in like 3 different ways. You can write it like this as an actual interval. You can write it as the point estimate plus or minus the margin of error. So that would be like you write it as p hat plus or minus your margin of error. Right? Like if I said I wanted to give you a range from like 6 to 8. Okay, let's see. I can write that in 3 different ways. I can say, all right, well, that's just from 6 to 8. Right? I can write it as this. 6 is less than x is less than 8. You can write it as a compound inequality. Or this is the same thing as saying 7 plus or minus 1. 7 minus 1 is 6. 7 plus 1 is 8. So we're going to use this method for part C. But I think they want the interval for this part. So there's our 90% confidence interval. It says then, what is the margin of error? So if I write my interval like this, the margin of error is the plus or minus stuff. Okay, you'll see when they were doing like the presidential elections, they were saying Biden was going to get 52% of the vote, plus or minus 1.7%. That's how off they can be by. That's their margin of error. So I need to figure out what am I adding and subtracting to get these 2 numbers. And what's the middle number? Well, the middle number here is our point estimate. That's p hat. So basically, to get these 2 numbers, I'm taking 0.575, and I'm adding and subtracting something. When I subtract that number, I get this. When I add that number, I get this. So to figure out what that is, just take the upper number, 0.6157. 0.6157. Whoops. Darn it. 0.6157 minus 0.575. So it looks like if I take 0.575 plus or minus 0.0407, I get these 2 values. Okay? So let's do this. Check this one. 0.575 minus 0.046. It might be a little off because it rounded up. That's 0.5343. So that's our margin of error. 0.0407. So a friend of yours claims that at most half of all teenagers would admit to texting while driving. Using your confidence interval from part B, do you believe this claim is true? No, 50% does not fall in here. The lowest value here is 53%. So no, since 50% does not fall in our 90% confident interval. And then it says, this. You said it's extra part. Let me just cut this off. So then this says, suppose you want a 90% confidence interval and want it to be within 0.2% of the true population proportion. Using part A as a preliminary estimate, how many teenagers would you need to interview? So this is actually notes that I give my class. So this is on for the PowerPoint notes for my class. Here's the formula we need to find sample size given a proportion. So it's n equals z of alpha over 2 squared times p hat times q hat all over margin of error squared. So the first thing we need is z of alpha over 2. That's the critical value. Whoops, that is not even straight. Sorry about that. That's the critical value. Whoops, oh, whatever. That cuts off the middle 90%. From a 90% confidence. So I want that value. So remember, I'm going to use my calculator to find this value, and I need to find the area to the left of that. So I have to include this piece also. If this is 90%, then this is 5, and this is 5. So there's 95% to the left of that z value. So I'm going to go to distributions, inverse normal. The area to the left is 95%, and it's a z-score, so it's 0 and 1. So my z-score is 1.6448. Now look, I have to take that in squares, so I'm going to do that right now. Take that, square it. Now I need to multiply it by p hat. P hat is right here, 0.575. I'll multiply that by 0.575. And then q hat is just 1 minus p hat. So if I do 1 minus 0.575, I get that. So I'm going to take this answer, multiply it by that. So that's the whole top. And I'm going to divide it by margin of error, 2%, 0.02 squared. So it looks like I need 1,652.9. Even if this was 1,652.1, always when you're finding sample size, round up, because you have to make sure you have enough people. If it's a fraction, going down might not make you have enough people in the sample. So this is going to be 1,653. It's still to where I can't read numbers correctly. 1,653 people. Okay, I think you're texting it right now. Okay, so the radio talk show host asked their listeners to call in about proposed pay increase for city council members. What yearly pay do you think council members should get? In all, 985 people called in. The mean pay they suggested was $8,740, and the standard deviation was 1,025. So this is based off the sample. So that's going to be S, not sigma, and then there's our X bar. So it says, based on the responses of those who phoned in, the station calculated with an approximate 95% confidence interval for the mean pay to be between 8,670 and 8,810. Explain why this confidence interval is not representative of the opinion of all citizens. Well, because this is a form of bias. I'm not sure if you guys have talked about bias. I assume you have if he's asking about it. But this kind of survey was only done by people who would take the time to call in. Like if you and your mom were sitting on the couch and this question came up on the news, I don't think either one of you would care enough to call in and give your opinion. So this is only, values are only given by very, very opinionated people in the population. This is called a voluntary response bias. So I don't know if you've learned that. If you use that, it might look fishy if you haven't learned that yet. But that just basically means that it's not representative because this is a poor sampling method. This is poor sampling. because it relies on only people with strong opinions to phone in. Right? If you go to a restaurant and the restaurant's okay, right? You have an okay time. You're not going to go on Yelp and write a review. You're only going to write a review if it's absolutely fantastic, or if your friend works there, or if it was absolutely horrible. So you're going to get 0 stars or 5 stars. So that's not representative of the population. And the technical reason why is because this is called a voluntary response bias. And the last one, if I can, there we go. The computer in some cars calculates the gas mileage in miles per gallon. The MPG was recorded. Each car's gas tank was filled, and the computer was reset. The values for a random sample of 25 readings is given below. Using a normal probability plot, is it appropriate to construct a confidence interval for this data? Let me just pause this, and I'm going to put this in my calculator. Okay, sorry, they're blowing the leaves outside my house now. All right, so you'll notice I put in my stat menu all the data into L1, and then I did a stat plot, went to plot 1, turned it on, and I just plugged in a histogram, third option, and then I used the X list, and all the frequencies are 1, and then when I want to graph it, I'm going to hit zoom 9, and you'll see there's a graph of the data as a histogram. And we can see that it is roughly bell-shaped. Okay, so we can assume that the data is normal. I don't know if you want to explain, you could draw a picture, or you could just say that you graphed it in the calculator and it looked roughly normal. I mean, that would be good enough for me. I'm not sure what exactly he wants. Well, Robbie's going to start barking. Sorry, they're blowing leaf here outside my patio. Okay, so that should be good enough. I would just say something about I graphed it, plotted the calculator. You could draw a rough picture, but just say that the graph is roughly bell-shaped. So that says if it is appropriate, which it obviously is, construct and interpret 90% confidence interval for the mean MPG for this car. So the thing to remember is we don't know sigma. We're finding an interval for the mean, and sigma is unknown. The population standard deviation. When we don't have sigma, that implies we're going to use a t-test. If we did have sigma, that would imply a z-test. Okay, so we're going to get the calculator. Get out of this. Stats. We're going to do not a t-test. This is a t. We're talking about intervals now, not hypothesis test. This is interval. And this is interval. The next chapter you do probably will have t-tests and z-tests. So this is a t-interval. I'm going to use the data from my list. Everything in L1, their frequency is 1, 90% confidence. So my confidence interval is 22.973. Up to 25.027.